This is Study Guide for Unit 1.2, Proof 21. In Proof 21, you are given a diagram and you're asked to do a geometric proof. I've included some thinking space because I think we'll definitely need to think about this a little more than we do our algebraic proofs. So let's take a look at what we know so far, or what we can observe. We're given our diagram over here. We are told that angle 1 and angle 2 are complementary. We're asked to prove that angle 3 and angle 2 are also complementary. So the first thing I want you to do is to write down everything you notice about this diagram, everything that we know for sure, and this can be very informal, but write this down in your thinking space. This would be a really good time for you to pause this video and try this on your own before you hear what my thoughts are about this diagram. All right, I'm hoping you have thought about it for yourself. Let's write down some stuff we know about this diagram based on our given statement and based on the picture. So we're already told angles 1 and 2 are complementary. Remember, what that means is that their measures, so I'm going to say the measure of angle 1 plus the measure of angle 2 is 90 degrees. And any way you can capture that thought, that might be important, that might not be. We'll find out. What I'm hoping you also notice here is that we have a pair of vertical angles. So these angles 1 and 3, those are congruent because they're vertical angles. So I might write angle 1 and angle 3 are vertical angles, vert angles. I'm going to abbreviate. And hopefully I also know that means that vertical angles are congruent. It's totally okay if you go outside of the thinking space a little. We're telling you to think outside the box anyways, right? All right, let's think about anything else that we might know. And there's something that I know that's not marked, but I can prove it. And I'm going to prove it to you informally. We were told already that angles 1 and 2 are complementary, which means that they have a sum of 90 degrees. By the way, it's totally okay to write on your diagram as long as you only write down things that you know to be true on there. So something I know, even though it's not marked, is that I also know this angle is 90 degrees. And I know that because this is a line. And we said in geometry, if it looks like a straight line, we're going to assume that it is. So if that's 90, this must be 90 so that it equals 180. So maybe that will be important, maybe it won't be, but your thinking space is just that. Like, what are you thinking about this diagram? So I'm going to say the angle between 2 and 3 is 90 degrees. Maybe that will matter. Maybe it won't matter. Let's think about this a little more and figure it out. All right, so what I might do now to kind of formalize my thinking is let's see if we can come up with a path to get to our statement. So we said that angles 1 and 2 are complementary, and I'd be doing this in my thinking chair. I'm just going to write TC right here for thinking chair since I didn't draw a cute thinking chair. But we said 1 and 2 are complementary, and we're trying to prove that 3 and 2 are complementary. Well, something that I know right now is that 1 and 3 are congruent. So I might more formally write like angle 1 is congruent to angle 3. And if I think about how I know that, we said over here that 1 and 3 are vertical angles. So I might write vertical angles just a little informally here. All right, the other thing I could think about is that if angle 1 is congruent to angle 3, I could really substitute 1 or 3, 1 for 3, or I could also use, which is probably a better one here, is I could use like the transitive property somehow. Because if 1 and 3 are congruent, that really means that the measures of their angles are equal. And that just has to do with what we know about congruence. I'm going to abbreviate that right there. So the other thing I might want to write in my thinking chair, which I know is kind of an informal place, is that right now something I'm thinking about is that I might be able to use substitution Or I might be able to use the transitive property. It just kind of depends which direction we go in with this proof. So I'm going to start writing this, and as you are working either with me or pausing the video and trying it first and then checking, which I would recommend, know that there's not just one correct path to this, but you're really looking, again, to make the most concrete and the most like detailed argument that you can make, just like you're at trial here. All right, so I hope I can fit this all in on this one page. We're going to begin with our given statement. We always start with what's given in our proof. So our very first statement, we're going to say angle 1 and angle 2 are complementary. I'm going to abbreviate that just because I'm running out of room. Okay, the reason for that is that it was given. So we always start with a given statement. Sometimes we'll have more than one. All right, so we know angles 1 and 2 are complementary. I think it would also make a lot of sense here to really go into more detail with that about their measures. So I might say next that the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Well, how do we know that's true? And again, you guys had that reference sheet that you need to know. You're not allowed it on the test, but we need to know, is this a postulate? Is this a theorem? Is this a definition of something? Or, how do we know, is this a property? So we should know that that's the definition of complementary angles. So when I make that statement, I could go ahead and say that's the definition of complementary angles. And again, if you abbreviate here, I'm okay with that. You need to check in with your math teacher about what they'll take. I will probably know what you mean if you say complementary angles. I'm only abbreviating because it's so hard to write on an iPad with my stylus. Okay, then if we think, what comes next? Or what can we say next that makes sense? Well, we've already proven that 1 and 2, or we've already really stated that 1 and 2 are complementary. They add up to 90. Now, that's all we can say about 1 and 2. We need to get angle 3 in the game there. So going back to our thinking about this, we said that angles 1 and 3 are vertical angles and that they're therefore congruent. If we use the vertical angles theorem, I think we can really knock out in one step, and we can say that they are vertical angles and that they're congruent. So in my third statement, I can go ahead and assert that angle 1 is congruent to angle 3. And again, you might want to say the definition of vertical angles there. Probably the most precise way to name this is the vertical angles theorem. And again, just check with your teacher about acceptable abbreviations. I've seen VAT. I usually abbreviate it like I just did. Vertical angles theorem. All right, so we've proven that 1 and 3 are congruent. But if you look at the statement that's really joining 1 and 2, kind of where we left off over here, we're talking about their actual measures. So what I think we really need to do is go from the statement about the congruence of the angles to their measures being equal. And that's easy because that's the definition of what congruence is. So again, I know this might feel unnecessary to some of you, and I think when I was taking geometry, this felt unnecessary to me as well. But we're trying to make the best case that we can. So we're going to say the measure of angle 1 is equal to the measure of angle 3. And it's congruence that allows us to say that. So my reasoning here would be the definition of congruence, which I'm okay with. If you want to be even more specific, you could say the definition of congruent angles. I will take definition of congruence, though. I think that's plenty specific enough. All right, so now we've established that their measures, are equal. So now, because we have equality, I could really do one of two things. And actually, as I take that back, I think really one is going to be appropriate here. So I mentioned earlier that we could use substitution, or we could possibly use the transitive property, but if you look at the transitive property of equality, it says like we would have to have a little more information. So I'm going to kind of scratch my thinking on that. And again, that's why the thinking chair is there, is because you might think about something and then later realize, that's not going to be helpful here. So in order to use the transitive property, I have to have like one thing congruent to another, and we don't quite have that here. So we're just going to use substitution. So if we go back and again look at this statement, we said that measure of angle 1 plus the measure of angle 2 equals 90. And we've now in line 4 established that these are equal to each other, and therefore one could be substituted for the other. So in statement 5, I'm going to say that the measure of angle 3 plus the measure of angle 2 equals 90 degrees. And if you're thinking like, where did she get that from? Again, this is just, oops, see if I can highlight it. We're substituting, that was supposed to be a highlighter, sorry. It's the end of the day and I'm exhausted. We are substituting this because we said in this statement that 1 and 3 are equal. So we're substituting the measure of angle 3 up here in line 2, where we originally had the measure of angle 1. All right, let's see. And then lastly, in number 5, oops, I wanted to do that in black. Doesn't really matter. In number 5, we're going to say the reason for that is the substitution property. So substitution property of equality, I will take substitution property. All right, so we're almost done. We're almost done. You might feel like we're done. You might be like, hey, I proved it. But if you look up at this statement, it says prove that angle 3 and angle 2 are complementary, not prove that their measures add up to 90 degrees. And I know that might seem like the exact same thing, but our final statement really needs to be that statement next to prove. So I'm going to say angle 3 and angle 2 are complementary. And again, the reason for that is going to go back to the definition of complementary. So when we said in line 5 that their sum is 90 degrees, that's the definition of complementary angles. And that's it.